Here's a shout out for Balkaran Man. Did I pronounce it all correctly? I'm all good? Awesome. This is Mr. Willard's class. We're taking a look at linear functions. And Balkaran actually asked for that. He said, can I get a shout out? So I kindly obliged him. You want who? Manit, do you want to get a shout out as well? Okay. Manit, say it really loud.
Hi, Mom.
Yes, that's Manit Gill saying hi to Mom. So we've got our point-slope form here. So point-slope form is a really useful form of a linear equation. And let's quiet down here. So the equation of a line that passes through the point x1, y1, so this is a given point, and has a given slope of m, is provided by the equation y minus our y1 value is equal to the value of the slope times x minus our x1 value, close brackets. So for this one, we want to determine, using this formula, the equation of a function that passes through negative 3, 7 and has a slope of negative 2 over 9. So first thing we're going to do is we're going to match up our x1, y1 terms. So what we can see here is that our x1 term is negative 3, and our y1 term is equal to 7. And just for clarity, our slope, m, is negative 2 over 9. So the nice thing about the point-slope form is that from here we simply make the substitutions into the general form. So we're going to take those values and substitute them in here. So let's see what we get. I'm going to have y minus the value of y1, so y minus 7, is equal to my slope of negative 2 over 9 multiplied by the bracket of x minus my x1 value of negative 3. And we might want to clean this up just a little bit. So for instance, if you have brackets, well, like double negatives, so we can make this into y subtract 7 is equal to minus 2 over 9 onto x plus 3. You got it.
Fractions with the negative sign, does it just go like in the middle, or do we put another number that's negative?
You get to decide. So remember what we said is that when you have a fraction that's negative, you get it one negative sign, you get to decide how you spend it.
Okay,
so it's personal choice.
It's generally put in the middle.
Yeah, it's either put in the middle, up top. The third way that's equal to is if you put it on the bottom, though this one generally isn't used, but it's not incorrect.
Okay.
But it's good to know that all three options are available. Thank you for that question. Okay, so that's our point-slope form. So point-slope form is kind of like our ultimate form. It's the best form for just given the smallest amount of information, how can we get what the equation is? So we're going to take, oh, sorry, did you need more time? Okay, so let me just kind of summarize here. So the idea is that the smallest amount of information which can define a linear function is just two individual points. So from any 2 points, using our point-slope form, we can determine what a linear function is. So let's take a look here. So we can also use the point-slope form in reverse. Okay? So we can pull information out. And that is what was our reference point, or the point being referenced, and what was the slope of the line. So let's take a look here. We're going to compare these to y minus y1 is equal to slope onto x minus x1. Okay? So we're going to pause here, and I want you to find out what's the value of y1, m, and x1. So when we're taking a look at these, remember that we have y minus y1. So for instance here, y subtract 11, what's being subtracted matches up. So I can know right away that y1 has to equal positive 11. Okay?
Oh,
That's okay. That's okay. So here, the number in front of your brackets here is equal to your slope. So here, my slope is equal to negative 11 over 3. And this one's only the real tricky one. So notice that what I need to find is x take away some number. So what's another way that I could write this? Instead of x plus 3, I could write this as x subtract negative 3. So this value of negative 3 is the one that I want. So what I get is my x1 value is negative 3. Putting this all together, this gives me the point negative 3 comma 11 with the slope of negative 11 over 3. So a really nice way to pull out the information. Okay? So let's try the same thing with b. I'll pause here and we'll see how people do. So let's take a look here. So I can write this as y take away 0 is equal to 4 onto x minus negative 1. So remember, if I have x plus 1, that's the same as x subtract negative 1. Now I can compare this to y minus y1 is equal to m onto x minus x1. So let's pull out our information here. So what's the x1 value? Negative 1. And what's our y1 value? 0. Now what's my slope? Perfect. 4 or 4 over 1. Absolutely correct. Okay. So there we go. So on to our next page here. So we're going to be able to, using the, rather than the point slope form, rather than the slope intercept form, we're going to use the point slope form. So notice here that the y-intercept is some non-integral value, right? So here it doesn't cross, neither of these cross the y-axis at some integer value. So instead, when we don't have it crossing at an integer value, we're going to use the point slope form. So I'm going to label this guy over here is A, and this guy over here is B. Okay? So first we're going to do for A, and then we're going to do for B. Yeah. So we get y minus y1 is equal to the slope onto x minus x1. Okay? So the first thing that we want to find out is we want to find the slope. And I've provided 2 integral points here to find our slope with. So for A, is the slope positive or negative? For positive, positive. Remember, hold up your hands, like make the roof, and your left arm is the positive slope. Okay? So we know it's positive. How much do I have to go up to meet this dot? 1, 2, 3, 4, 5. And how many do I have to go right? 3. 1, 2, 3. That's right. So we have a slope of positive 5 over 3. So now all we need to do is choose one of these integral points. So what's the coordinate of, let's say, this guy right here? What's its coordinate? Yeah, negative 1 comma 3. And the nice thing is it doesn't matter which point we choose. It will get the exact same equation no matter which point we choose. And that's the powerful thing about point slope form. Well, no, now we have to plug them in, right? So now we're going to plug them into our equation. So I should get y subtract 3 is equal to 5 over 3 multiplied by x subtract negative 1. Okay? Yeah, you can totally do that. I'm just showing the long form, and then the step you want to do is change that into, because anytime you have a double negative, just like in English, we don't use double negatives. Like, I never didn't do that. We don't use that because it's bad English. So same with double negatives in mathematics.
How did you
Yeah.
do negative 1 and 3? Sorry, I was writing that.
Yeah, no worries. So what I did is we're just using the coordinate for this given point. So it's negative 1 on the x-axis and 3 on the y-axis. Yeah. So what I want you to try now is we're going to do the same thing. I want you to find out the slope, and you can use one of the given points for line B. Okay, so let's take a look here. So to start out, our slope is negative, and I have a rise of 1 and a run of 5. And I can use either of these reference points. So I can either use 6, 5, or I can use 10, 4. Okay, it doesn't matter which point I use. So I'm going to do for both.
That's what I got too.
Sorry, am I not counting right? 1, 2, sorry. Apparently my prescription needs to be updated on these glasses. Sorry, which one? No, it's 10. That one's definitely 10. Ah, I can count sometimes. So I'm going to do both of these here. So I'm going to do this guy over here. So I get y take away 5 is equal to negative 1 over 4 onto x take away 6. And we'll use double asterisks for this guy. And remember, it's just an either, right? You didn't have to do both. And if you use this point, you'll get y minus 4 is equal to negative 1 over 4 times x minus 10. Manpreet, what's up?
Okay, you know where you got the x minus 6?
Mm-hmm.
Is that always going to be like minus and then the number?
Yeah, but if it's a negative value, because if you subtract a negative, then you can change that into plus. So that's what we were talking about with double negative. So for instance, up here, this was originally a subtraction. These were two subtraction signs, so x minus negative 1. But if you subtract a negative, it's the same as adding a positive. So we just want to simplify that.
So for this one, you were subtracting a positive?
Yeah, so subtracting a positive is just, it doesn't simplify.
Okay,
Yeah, beautiful. So any questions with that example? Okay. So, and the neat thing is that even though these look different, if we simplify and expand these will equal the exact same equation in both slope form and general form. Okay, so that's the power of point slope form, is that once we expand, and I'll show that at the end of today's lesson. We'll come back to this example. Okay, so taking a look at our next example here. Here we've got, I want to determine the equation of a line which passes through 11, negative 2 and is perpendicular to y equals 3 over 4x minus 5 over 9. So let's pull out our values. So what's my value of x1? 11. What's my value of y1? That's right. Now what's my slope that I need? I need perpendicular to this guy right here.
3 over 4.
Say again? Well, if it was parallel, it would be 3 over 4. But if it's
negative 4 over 3.
negative 4 over 3, that's right. Beautiful. So now we're going to plug it right into our equation. So y minus y1 is equal to the slope onto x minus x1. Okay, so I'll pause here and give you a 30-second head start. So let's see what we get. So let's do some green. So I'm going to get y subtract negative 2 is equal to negative 4 over 3 onto x minus 11. And I just want to clean this up so I can also have this as y plus 2. So if you went directly to y plus 2, more the better. Okay. So any questions with that example? Is that looking okay? Okay, let's take a look at this last guy here. So we want to determine the equation of a line which simply passes through negative 3, 13 and 9, negative 7. So this is kind of the least amount of information we need to be able to create a linear function. Just a set of 2 points defines a linear function. So we're going to come back to one of our previous equations. So the slope is equal to y1, or sorry, I think it was y2 we used in our equation. So y2 minus y1 divided by x2 minus x1. Okay, so that's what our slope is. And now for our x1, y1, and our x2, y2, we can choose whichever. So I'm going to say that this is my first set of points, and this is my second set of points. So I'm going to have an x1 equal to negative 3, a y1 equal to 13, an x2 that has a value of 9, and a y2 which is equal to negative 7. Okay, so is that part okay? Just pulling out the values? Okay. So what we want to do now is we're going to substitute these in to our slope equation. Okay, so I'm going to pause here and give you a head start. So we're going to substitute these values into our equation here. So I get negative 7 subtract 13 over 9 subtract negative 3. So we're just going to simplify. So in my numerator I get negative 20. My denominator I get positive 12. Remember, subtracting a negative is the same as adding a positive, so that's where our 12 comes from. And this can be simplified. Both of these are divisible by 4, both the numerator and denominator. So I'm going to get negative 5 over 3. And this is our given slope. Okay? So from here, I have my m, and now I get to choose which point I use. So let's take a look. If I use the equation, y minus y1 is equal to the slope times x minus x1, let's do both of these. This will be good practice. So I'm going to use my first point here. So we're going to have negative 3, 13, and I'm going to have a slope equal to negative 5 over 3. So I'm just going to scroll up here. So substituting in for these values, I'm going to have y subtract 13 is equal to negative 5 over 3 onto x plus 3. Okay, so I did the fast method. I know if I'm subtracting a negative, it's the same as adding a positive.
Why didn't we use the second formula for we use 13?
Oh, because that's the formula. Remember, it's y minus y1 and x minus x1.
Oh.
So the idea is you subtract your y value from y and subtract the x value directly from x. And actually in grade 11, we use this same process to move and shift around and alter other forms of equations. So this is kind of a foundational look at what's called function manipulation. So how can you make functions look the way you want? What do you have to do to them to twist them around and get them to be exactly what you need for your models? So let's do the same thing here, except now I'm also going to use instead the point 9, negative 7. And we're going to show that the two equations we get are indeed exactly the same. So in this case, I'm going to have y plus 7 is equal to negative 5 over 3 onto x take away 9. And that's just using our substitution values here. I'm just going to redo this guy. I'm just going to put this in red just so it matches up a bit better. So 9 minus 7, comma. Okay? So what I want to do is I want to show that this linear function is the same as this linear function. All we're going to do is let's get some practice putting this into standard form, okay, into slope-intercept form. Grab a little bit more space. So we're going to start with our green guy. So in order for me to change this, what I have to do is two things. I have to use the distributive property. Then afterwards, I'm going to add 13. So when I use the distributive property, I'm going to get the following. I get y subtract 13 is equal to negative 5 over 3x. And negative 5 over 3 times positive 3 is just negative 5. So now I add 13 to both sides. And what I'm going to get is y is equal to negative 5 over 3x plus 8. Okay? So, pardon? Well, we're going to show, I'm going to show that the one in green, this guy, is actually the exact same as this guy. It's a way to check your work.
What did you do there then?
As my first step?
Yeah.
Okay, so the first step is I used the distributive property. So I distributed my negative 5/3 through the brackets, right? So negative 5 over 3 times x is negative 5/3 x. Negative 5 over 3 times 3 is negative 5. And then as my last step, I added 13 to both sides.
Do we have to do that on a test?
If it asks for it to check, yes. So now I'm going to do a similar process for my guy in red here. First step is I'm going to use the distributive property. So I get y plus 7. Can someone grab the door for us, please? Thank you very much. So negative 5 over 3x and negative 5 over 3 times negative 9. Hey, how's it going, Jaden? Is equal to positive 15. Okay. So now what I want to do is I'm going to subtract 7 from both sides. And we get y is equal to negative 5 over 3x plus 8. And we find, amazingly enough, Mr. Willard was right, that this guy here, I need a bigger pen, this guy here is the exact same as this guy here. So just to confirm that it does not matter which point you select, you'll always get the correct value. Okay. So would people like me to go back to that other example to go through the same steps, or do you want to go over to homework right now? Yeah, you can finish writing this down, of course.